Hi, this is Mo. Now I'm doing the homework 10, question 1. From the lecture notes, collect the definition and the simple properties such as probability mass, mean, and the autocorrelation function of samples of stochastic process. The first one is Poisson process. The definition is the number n of T1, T2 of points T1 in the interval T1 and T2 of length T equals to T2 minus T1 is a Poisson random variable with parameter lambda T. The function is just like this. And when x of t is equal to n of 0 and t, we can draw the distribution function of x like this one is a stair, just like the stair. And the first order probability mass is px of t equals to k is e power of minus lambda times t times this function. And the mean value is lambda t. The autocorrelation value of Poisson process R of T1, T2 equals to lambda square times T1 times T2 plus lambda times mean value of T1 and T2. And the autocovariance value CT1 T2 equals to lambda times mean value of T1 and T2. From the mean value, we can see that the mean of Poisson process is lambda times t. It's the linear function of t. That means when longer times we wait for the expected number of points in the interval of t is larger. And the autocorrelation function contains the term minimum value of T1, T2, which means from this property of with independent increments. And the second process is Poisson increment process. The definition is y of t equals to x of t plus delta minus x of t and divide delta. This is a kind of like derivation. The first order probability mass was probability of y of t equals to n over delta equals to this function. And the mean value of y of t is equals to lambda, and the autocorrelation value is equals to this part. It can be divided into two sections. When T1 minus T2, the absolute value of T1 minus T2 larger than delta, and the absolute value of T1 T2 smaller than delta. And also the autocovariance value is divided by these two conditions. And from the autocorrelation value, we can see that in this part, when absolute value T1, T2 is smaller than delta, the autocorrelation value is just like a triangle. And otherwise, it was just a constant equals to lambda square. And the third process is point impulse process. It can be written as c of t equals to the derivative of xt over dt. Xt is Poisson process, and the probability mass of this process is no definition. There is no specific probability mass of this process. The main value of this process is lambda, and the autocorrelation value is lambda square plus lambda times delta T1 minus T2. This is the impulse signal, and the autocovariance is equals to lambda times delta T1 minus T2. The distribution function of this impulse process is just like this part. Oh, this is t, and this is t. We can see that it's just some impulse signal. Under the process, z of t minus lambda is have the mean value of 0, and the autocorrelation value lambda times delta of T1 T2. So this part is a white noise. And the first process is semi-random telegraph signal. We can define it as when we suppose x of t is we suppose that p probability of n t1 t2 equals to k is this part. This is a Poisson process, and when k is equal to is even number in 0 and t, that means in t times there are even points in this interval of time, and under this condition x of t equals to 1, and when in the time of t there is odd number of points correct in this time interval is, so x of t is -1. So the first order probability mass function is these two parts: probability of when x of t equals to 1, the even number, and probability of x of t equals to -1. The mean value of this process is e power of -2 times lambda times t, and the autocorrelation value is this part: e power of -2 times lambda times the absolute value of t1 minus t2, and the autocovariance value is like this part. And the distribution of semi-random telegraph signal is just like this graph, and when t equals to 0, x of t always equals to 1. And the next is random telegraph signal. This process is defined as y of t equals to a times x of t. X of t is also a semi-random telegraph signal we discussed above. So a is also a random variable. The probability of a equals to 1 equals the probability of a equals to -1 is half. And the first order probability mass function is half. The mean value of this process is equal to 0. The autocorrelation value is equals to e power of -2 times lambda times the absolute value of t1 minus t2, and the autocovariance value has the same value with rt1 t2. Because the first order probability mass function, we can guess that y of t may be a straight sense centenary process. Also because the expected value of x of t is equal to 0. So this process we can guess that is a straight sense centenary process. So the number 6 process is random walk. random walk is we can guess that we toss a fair coin n times. K is the number of heads in n toys, and x of n times t is equals to k times s minus s times n minus k is equals to this formula. And the first order probability mass is equals to this part. And the mean value of this process Ex of t is equals to 0. The autocorrelation value and the autocovariance value has the same value, equals to minimum of n and m times I squared. From the probability mass function, when n goes to infinity, we can have a Gaussian density, and the correlation function contains the minimum value of two variables. So we can guess that this is a portrait of independent increments. And the last process is Wiener process. This can be defined as W of t equals to the limit value when t goes to 0, s squared over t goes to alpha, and n goes to infinity, the limit value of x of t. X of t is a random walk. So the first order density function is this part. It's just like the normal distribution. It has the same formula with Gaussian with normal distribution, and the mean value of this process is equals to 0. The autocorrelation value and the autocovariance value has the same value as minimum value of t1, t2 times alpha. So this process is a Gaussian increments, and also it is because this part in correlation values, this part is also an independent increments. So that's the answer of question 1.